Hello, welcome to the fourth lesson in this series on learning Python for beginners. In this lesson, we'll learn how to use user input in our commands and programs. In this lesson, we'll recap what we've learned about functions, and we'll look at a special function that captures user input. We'll look at how we can design prompts to make our programs easy for users to understand, and how it's important to think about the data type of user input. We've already learned quite a lot about Python expressions, so let's just review what we've already learned. An expression represents a value, and if you enter an expression into the Python shell, the computer will evaluate the expression. There's a couple of things that you can do in the shell. You can either display the value of the expression, or you can tell the computer to store the value as a variable. And the computer will pick a suitable data type for the variable based on whatever the value is. So if it's an integer, if it's a float, or if it's a string. And we've seen that the computer will use different storage methods for those different values. A Python function is a type of expression. That is, it represents a value. A Python function takes in a value, transforms it in some way, and generates a new value. For example, we could take the number 99, we could put it into the str function, the str function, and that would convert it into a string. The numbers 9 and 9 in a string format. Every function has the same structure. We see the name of the function followed by brackets. A value goes inside the brackets. That is called the parameter, and the parameter is the value that goes into the function. Every function creates a value because a function is an expression. It expresses a value, and the value that is expressed by a function is called the returned value. So let's have a look at an example so we can see this in action. Here's a function, it's called int. It converts whatever is inside the brackets into an integer. So the parameter of this function is the string 99. The function is called int, and the returned value is the integer 99. And the computer has evaluated the function and displays the value. As an alternative, we could store the returned value as a variable. So in this line, we've stored the returned value as a variable called x. And if we type x, the computer will evaluate x and show us the number 99. Or we could use a new function. This one's called float. So the function is called float. The parameter is x. And the returned value is stored as a variable called y. And y now stores 99 using the float method. Let's stop for a moment and look at the colors here. You can see that the Python shell, uses black to represent the name of variables and symbols such as brackets and equal signs. It uses blue to show its returned values, and it shows green for strings. The names of functions are shown in purple, and these are Python inbuilt functions. Later on, you'll write your own functions, but for now we're using the functions that come as part of Python, and the ones that we've been looking at are the ones that convert data types. Now we're going to look at a new function, and this is a function that lets us collect input entered by the user, typically by typing. Really, we need to be able to collect numbers from the user to create any kind of useful function, useful programs. Otherwise, our programs can only use values that have been written by the programmer. The Python input function is called input. The user enters a value, the function returns the input value, and the computer can display or store the returned value. So in the Python shell, if I enter the name of the function, I haven't even given it a parameter, the program will wait until the user types something. Here the user's typed 99, and the computer has immediately displayed the value of the returned value from the function, which is what the user has typed in. But we normally don't use input like that. We normally put something inside the brackets. And what we put inside the brackets is the prompt. The prompt will tell the user what to type. It would be displayed on the screen, and that is very helpful for the user. So here we've got the same input command, but I've written enter a number as the prompt. The prompt is displayed, enter a number, and the user has typed 99, and the computer has evaluated that expression. It looks a bit messy because the input and the prompt actually touch each other, and it doesn't look all that nice. So I always include a space at the end of the prompt. In fact, I usually include a colon and a space because I think it makes it a bit clearer. So there we go, enter a number with a colon and a space, so that the user's input 99 is spaced away from the prompt, but it's the same result. The computer accepts the value 99. So let's just quickly recap. Input is a function. You should include a prompt inside the brackets, and the computer will display or store the returned value. So enter 99 or store the value as X, and then if you give the computer the expression X, it will evaluate it as 99. Now there is one problem with input in Python. The returned value is always stored as a string, never as an integer or a float. Even if you type numbers, it will be stored using the string data type. That means we can't use user input in calculations. Let's look at an example. Here I've asked the user to input a number, and I've stored it as a variable called X. In my next command, I try to add 1 to X, but I get an error message. The computer has tried to concatenate. Remember that the plus sign, when you're using strings, the plus symbol is used to concatenate, and it's saying it doesn't like to try to concatenate an integer with a string. We've learnt about that already. So how do we overcome this problem? The solution is that we always need to convert our returned values, our input values, to a number data type if we want to use them in calculations. Let's look at an example. Here I've input X and Y. I've input two values, 99 and 101, and I've stored them as variables called X and Y. If I ask the computer to evaluate X plus Y, it's concatenated the strings 99 and 101. That might be what I want, but in fact what I wanted it to do was to add the two values. So I'm using some of the functions that I know already to convert X to an integer and Y to a float data type. And now look what happens when I add them. It adds them together to give the result I want, 200. Incidentally, that result is shown as a float because if you add an integer and a float, you'll get a float answer. Okay, so it's as simple as that. So whenever we collect inputs, if we want to use them in calculations, we need to convert them to a numerical data type before we use them. Here's a complete worked example. In this is a series of commands I've entered into the Python shell. I've taken the user input and stored it as a value called height. I've taken the user input again and stored it as a value called width. I've converted them both into the float data type, and then I have multiplied width by height and stored it as a variable called area. And because I input the values 15 and 2.3, my resulting area is 34.5. So this series of commands allows us to calculate the area of a rectangle from input values, which are its height and its width. So I'd like you to stop this video, pause the video now, open Python and enter those commands into the shell. You can enter the inputs that I've used here, 15 and 2.3, or other inputs, and just see what result you get. And your final challenge is to complete this exercise. The area of a triangle is half the size of the base multiplied by the height, the perpendicular height of the triangle. So enter commands into the Python shell to input the base and height, perpendicular height of a triangle, let's say in centimeters. Convert those two variables into suitable data types and create an expression that will display the area of a triangle. If you can do that, then you can be confident that you understand Python functions and expressions and can create suitable numerical calculations. So in the next presentation, we're going to put everything that we've learned so far together to create programs which will store our commands. See you in the next presentation.